GridToPix is a fresh take at training visual embodied agents with minimal supervision. This work is a joint effort of researchers at the University of Illinois and Yale Institute for AI. We aim to answer the question, how to train visual agents with only terminal rewards. This is important because, first, current visual agents require shaped rewards to learn any meaningful policy. Rules need to be handwritten for every task which isn't scalable. And second, training of visual agents with only terminal rewards fails spectacularly. Let's make each of these points more concrete. Prior work which trains visual RL agents uses handcrafted and shaped rewards, which are dense indicators of success. For instance, for the furniture moving task, the agents are given a positive reward whenever they move the furniture item closer to the goal. Similarly, in well-studied point goal navigation and Google football tasks, positive rewards are shared whenever the agents get closer to the goal. It obviously isn't scalable to shape rewards for every single task in visual environments. It is therefore important to understand how we could avoid this. One way to reduce reward shaping efforts is to just train from terminal rewards. When we use the term terminal rewards, we mean that the goal dependent rewards or success rewards are available only at the end of the episode. Obviously, terminal rewards help save the effort of shaping rewards. Moreover, terminal rewards provide a general way of giving supervision to RL agents. Why? Because as we aim to solve harder tasks, it's impossible to explicitly write rules to give shaped rewards to RL agents. Unfortunately, just using terminal rewards fails spectacularly. Across simulators, we found agent success drops to near zero when learning from terminal rewards, despite training for millions of steps. How can we fix this? That is, how can we train visual agents with just terminal rewards? We suggest to create Gridworlds, that is, perfect perception mirrors or wrappers of visual environments. These Gridworlds enable to decouple the planning and perception components of visual agents. That is, we first learn policies of complex tasks in Gridworlds via general purpose terminal rewards, and subsequently we distill the Gridworld policy into a visual policy using imitation learning. Importantly, we can directly deploy the learned visual policy with no need of the Gridworld during testing. Let's now discuss the two steps of creating Gridworlds and decoupling planning and perception in more detail. Our proposed Gridworlds are perfect perception wrappers of visual environments. What do I mean by that? Perfect perception means that semantics are provided directly to the agent in its observation, so no or very little perceptual reasoning is needed. Most of the building blocks to create these grid worlds are already available in existing simulators. For AI to Thor and AI Habitat, the grid worlds capture a top-down tensor storing semantics for each spatial location in the map. For tasks in Google Soccer and OpenAI MP environments, we use the non-visual mode, which has access to clean environment variables like location and velocity. Overall, grid worlds capture key semantics and provide it directly to the agents. Importantly, while visual agents were not able to train from terminal rewards, Gridworld agents can. With just terminal rewards, Gridworld agents were able to achieve a success of 56% on furniture moving, a 78 SPL on point goal navigation, and a 0.9 game score in Google Football. This well-performing Gridworld agent, which we obtained by using just terminal rewards, can now serve as a teacher policy to supervise learning of perception. Specifically, in stage 2, we train the visual agent by receiving free supervision from the corresponding Gridworld teacher. We can execute actions in tandem in both the Gridworld and the visual environment and use imitation learning to distill the Gridworld policy to a visual policy. At test time, the visual agent can be deployed to new environments with no need for access to Gridworlds or the teacher policy. Recall that visual agents failed when learning from terminal rewards, and that Gridworld teacher agents worked really well. We can GridToPix our way to learn significantly better visual policies from these Gridworld experts while still working with only terminal rewards. Even if you wish to use shaped rewards, GridToPix may actually yield better results than directly training visual agents. To summarize, we show that visual RL agents fail to learn from terminal rewards. On the other hand, perfect perception or Gridworld counterparts work really well with terminal rewards. Our GridToPix methodology decouples planning and perception. Particularly, it creates a Gridworld teacher to train a better visual student. We demonstrate drastic gains across 4 simulators in the terminal as well as the shaped reward setting. Finally, we encourage the community to release a perfect perception wrapper or Gridworld when releasing a new benchmark or simulator.